Hello, everyone. Good morning. My name is Fatih. I'm an Android lead at DNB Bank. Most probably you haven't heard DNB Bank. It's the largest bank in Norway. So today we're going to be talking about using Kotlin Flow in MVVM architecture. I would like to say that you can find every code sample in my GitHub repo, and you don't need to worry. I'll be sharing these slides after this presentation from my Twitter account. So today's agenda is, first, we're going to be talking about how we can use LiveData in MVVM. I'm sure all of you know that, so I'm going to keep it short. And then we're going to see how we can use LiveData and Flow. And then we're going to say goodbye to LiveData and use only Flow. Then, at last, we're going to see how we can test all this stuff. So LiveData is very cool, right? LiveData is lifecycle aware. Because it's lifecycle aware, there is no memory leak. And whenever another observer comes, there is a cache, built-in cache in LiveData. So it's going to be provided by the latest value, so on and so forth. And at the same time, on the other hand, LiveData has some other disadvantages. LiveData doesn't support back pressure. What I mean by back pressure is whenever the producer side is faster than the observer side, only the latest value is going to be provided by LiveData. So the values in between of the producer and the observer is going to be lost. Only the last value is going to be provided in LiveData. And the other thing is when it comes to data transformation. It's a bit hard with LiveData because if you're using transformations, then you're going to be basically doing everything on the main thread. So you don't have any other way to move that stuff into background thread. Of course, if you're using LiveData Builder, it's obviously like you can do it on the background thread, but still it's a bit hard when it comes to data transformation. And yeah. Obviously, it requires lifecycle owner to observe like an activity or fragment. This is not a disadvantage, but when it comes to like when you want to observe the LiveData in some repository layer or something, then you might be thinking, should I send my lifecycle owner to repository or not? So it's basically a not good practice to send the lifecycle owner to repository. So this is a question mark. And today, we're going to build one app. In order to demonstrate all this stuff, we're going to do two things. First, we're going to be doing one-shot request with LiveData and Flow. And then we're going to be seeing how we can actually read some real data streams from the server. In order to build that, we're going to be using LiveData in the vModel. And then in the repository, we're going to be using suspend function for one-shot request. So let's start with the repository. In the repository, what we are going to be doing, we're just going to be doing one thing. We're not going to make an actual API call, but instead, I just added a fake API call, like a delay, 1 second delay. And then, since it's a suspend function, you can call some suspend function, edit delay, and then we are going to be just returning some random value as a result, just like assuming that it's coming from the API. So now it's suspend function in the repository. Let's go to vModel. But before going to vModel, I would like to say that sometimes you don't want to go to API every time you call this function, right? If you have some like cache, built-in cache or something, then you might want to get it from cache and then return that cache to vModel or call the API. Like you can decide which one to return, but with this function, you can only return one thing, not multiple things. Like you can't return, you can't return the cache value and the API value at the same time. And in the vModel, we have LiveData. As you can see now, we have LiveData in the vModel. And whenever you call the fetch weather forecast, before you have to kind of send some state to UI. Some loading state, right? Because in the repository, we're not sending any loading state. So in order to say UI, hey, it's loading, we have to send some loading state. And then we are going to call our suspend function from the repository. In order to call the suspend function from the repository, you need a Coroutines scope, which I'm using vModel scope here. And then when we get the result, we're just setting the result in the LiveData, and then we're done. But the thing is, every time before calling this function, suspend function, with this approach, you have to send some loading state to UI, right? So this is a question mark, and we are going to be solving this with Flow later on. So how about returning multiple values? We have talked about like returning some loading state and at the same time returning some cache value, and if you need to go to API, then you have to like kind of like return that API result, etc. So let's see how we can actually see this in action in the Twitter app. So when you open the Twitter app, you see some tweets, right? First you see some tweets. It's coming from the cache. And then you see some new tweets, which is basically coming, like, they are new, they are fetched from the API, and you're basically shown the tweets which are fetched from the API. So when you open the Twitter app, you get the tweets from the cache, and you update the UI, sorry. So you update the UI, and at the same time, you're fetching the new tweets from the server, and then you update the UI again. So how can we do this with the suspend function in the repository? Basically, in our case, it's first we want to return a value from the cache, and then we want to return the result from the API. But with suspend function, actually not suspend function, with a normal function, it's not possible because you can only return a single value with a function. So here, where Flow comes into play. So let's look at what Flow is, and let's look at how we can solve this problem with Flow. So Flow is a reactive stream which can return asynchronously computed values. And Flow, because like Flow is inside the Coroutines, you are actually making use of the structure concurrency, which is coming from the Coroutines. And Flow is called a call stream, which means that whenever you collect the flow, it's active. Whenever you don't collect this, it's inactive. And it has an efficient data transformation with the intermediate flow operators. And it's really easy to test. You can just test it like testing a list. So now we're changing suspend function in the repository with Flow. And in the V model, we're going to be using LiveData. So in order to change the suspend function, we just remove the suspend modifier. And then we basically just use the flow builder. So this example is not a real world scenario example because it's like, it's not calling the API. I just added, for simplicity, I just added a delay. So first, what it does is it just emits the loading state. In Flow's terms, it's the emission. You can emit as many values as you want. So first, we're emitting the loading state, and then we're assuming that we're making some API call, delaying for 1 second, and then we're emitting the result which is fetched from the API, which is actually here a random value. So the thing is now, how are we going to call this function and then use it in the V model? Let's see how we can do that. In the V model, now what we are doing is we are calling the repository fetch weather forecast method, and then since it's returning a flow and we want to use LiveData, how are we going to turn Flow to LiveData? So luckily we have an extension call as LiveData, which is coming from the lifecycle. So we can just use it, and then we can, like, the flow is going to be converted to LiveData. And in the fragment, I just wanted to show that it's like a normal observing LiveData. But the most important thing is, if you don't observe the LiveData, then the flow emission is not going to start. So it's really important to start the observation of the LiveData. Otherwise, you're not going to start the emission inside the flow. So, and the other scenario, we have talked about one-shot requests, right? So it was just one-shot request. You're just making some API call and getting the result and then sending it to UI. What about like if it's a data stream, like a real-time data? So let's say you have some VCM or something like that. So it's a callback, and then every time there is a new result, then you're going to be sending that result to UI. So how are we going to do that? In order to demonstrate, I just used while true, like it's the simple one that I can think of. So I just use while true, and inside while, we're basically what we're doing is it's a data per second. So here, what we are doing is we are just sending some random value to vModel, so to vLayer every second. So this is safe because we are using some coroutine functions here, like delay and emit. Whenever the coroutine scope, which is collecting this flow, is canceled, this while loop is also going to be canceled, because every coroutine function has a check if the coroutine scope is active or not. If it's not active, it's just throwing coroutine cancellation exception, and then basically it's just canceling all the things. And in the vModel layer, now we have, like, it's the same. We are still using LiveData, like this is Flow. We are using as LiveData extension. And then we are basically done. But is it all with Flow, actually? Like, is it just like this? No. We have talked about data transformation, right? So let's look at the intermediate Flow operators and how we can make use of the data transformation with Flow. So Flow has a lot of operators which we can make use of. We're going to be seeing everything one by one. So let's start with the map operator. Map operator, you can think of like it's the same with the list map operator, but at the same time you can call some suspend function in the maps lambda. So it means that you can actually do some asynchronous work with this map operator if this map operator is going to be happening, like it is going to be executed in some background thread. So here in this case, like let's say you are getting some Celsius degree from the server and you want to convert it to Fahrenheit. So you can just easily do it with map operator. And the scope that you're converting it to LiveData here, which is like the vModel scope, coroutine context, and the dispatcher default. So the map operator is going to be handled by a thread from the default dispatcher thread pool. So which means that it's going to be handled on the background. And let's say you want to send some loading state. Like we have talked about, we're sending some loading state every time we are fetching from the API. So you can make use of the onStart operator, which is going to send the emission before the collection start. And filter operator is the same with list filter, but as I said, it's like just like map operator, you can call some suspend functions inside. So if you want to, let's say in this case, let's just filter out the values which are less than 10 and then send it to UI. So we can easily do that with filter operator. On each operator, if you want to log some data or save it to your local database, each emission, I mean, then you can use on each operator and just do whatever you want. But on each operator, you're basically not sending anything to the collector side, but instead you're just doing something like logging, saving to database, whatever you want. And this is the one which I really like most. Whenever you want to change the coroutine context of the upstream flow, you can use flow on operator. So what I mean by upstream flow, in this case, all the lines above the flow on is called the upstream flow. But the thing is, if you add some other operators after this flow on, it might not be executed on the default dispatcher. It depends on the functions that you're calling after that operator. And you can obviously catch the exceptions from the upstream flow with catch operator. It's the same if you add some other operators after the catch one, then it's not going to catch the exceptions from that operator. It's just the upstream flow. And as LiveData, we have already mentioned as LiveData, if you want to convert flow to LiveData, you can use as LiveData, which gets the coroutine context as a parameter. Whatever coroutine context you give inside the as LiveData, it's just working like the same way as flow on working. So basically, the coroutine context is going to be applied to upstream flow again. So now we have seen how we can combine LiveData and Flow together. And let's go and see how we can use only Flow. Let's say goodbye to LiveData and use only Flow in all layers. So we have said that Flow is a cold stream. It's active whenever you collect it. It's inactive whenever you don't collect it. And it's not the same as LiveData. We have to keep in mind that like LiveData is lifecycle aware, but Flow is not. How we're going to actually make it lifecycle aware. So you hear like a configuration changes, etc. How are we going to fix those stuff? We need to keep in mind those. So now, since everything is actually the same in the repository layer, let's go to view model and change it to Flow, change LiveData to Flow. So how are we going to change this? Here, I'm really sorry about the name. It was a sample that I was using, so it turns out that it's really long. But let's go back here. So now we don't have as LiveData extension. Instead of just using as LiveData extension, now we're just removing that, and now we have only Flow in the view model. But the cool thing is now, how are we going to, with LiveData we were observing in the view layer, right? Now how are we going to observe, or in Flow terms, it's collect in the view layer? Let's go and see how we can actually collect the Flow. So Flow has operators called terminal operators, which starts the collection of the Flow. So obviously we have a collect terminal operator. We can use it, but in order to use it, it's a suspend function. It needs to be called from the coroutine scope. So now we're going to be thinking, which coroutine scope should I use? What is the right one? So here, I used the lifecycle launch when started. So you might be thinking, why not lifecycle.launch? So let me explain it why. So if you're using lifecycle.launch, then you start the collection. Then let's say users just decided to go to another screen, but the background process is still there. And then you're still actually collecting because it's not canceled. The lifecycle scope is only going to be canceled when the fragment is destroyed, not its view is destroyed. So the background process is still there, but user is in another screen. And then when the collection happens, like it's going to come here. If you're using launch, then basically there is no check. Then you are going to try to update the non-existing UI, and then you're going to get a crash. But if you're using launch when started, it's going to have a check. If the lifecycle state is at least started, or maybe you can use resume. If the lifecycle state is at least resumed, then it's kind of safe, because you're still wasting resources at the background, but it has a check, it's safe, you're not going to get a crash. Or you can use the repeat on lifecycle APIs, which is recently in, I think it's release candidate. It was in beta, and last time I checked, it was in release candidate. You can use also. And then it's going to, what it does is it's going to cancel all the ongoing work when the lifecycle is inactive, and then it's going to start the work when the lifecycle is active. So, is that all? Are we finished? No. This is the thing that I most like, testing. Most of the developers might not like this, but let's go and see how we can test Flow. So with LiveData, if you're somehow using LiveData with Coroutines, I'm sure you have seen some race conditions because of, either it's because of Coroutines or it's because of LiveData. Like for example, if you're using post value, how are you going to change, it's going to be happening on the background thread. How are you going to change those post value background thread to main thread? Then you basically need to use the instant task executor rule. And then with Coroutines, if you're using some other dispatchers like dispatcher default, dispatcher IO, then it's going to be using a background thread, not main thread. Then you also need to just change it to main thread in order to just execute everything on the same thread. So you need to keep in mind all of those stuff. And additionally, if you're also using transformations, you also need to remember to observe the resulting LiveData, which is coming from the transformation. Otherwise, you're not going to get any updates for the second LiveData. So as you can see, there are a lot to remember with LiveData. But when it comes to Flow, it's just easy. Like, it's sequential. Because it's sequential, there is no race condition. And then you can just test it like a list with the toList operator. Or you can use some other operators and test the elements, number of elements you want. Now, let's see. Like this is our function in the repository. And let's see how we can test this function. Like first we want to test if it's loading, and then we want to test if it's success. How are we going to test it? in order to test it, we need to first create a coroutine scope. So there is something called run blocking, which basically creates a coroutine scope and then just blocks everything, and then everything is going to happening on the same thread. And then we're just calling the function from the repository, we're getting the flow, and now how are we going to test that? The first one is loading state, and the second one is the success state with this collect terminal operator. Basically, we can test it because we don't have an index. OK, let's go. We have another terminal operator called collect index, which is basically giving you the index and the value. Now we can test, like, if the first one is, assert that if the first one is loading, and then the second one is success. Also, you can, as I mentioned, you can also use toList terminal operator, which is, what it does is, it just starts the collection of the flow, and then gets all element which is emitted in the flow, and then put the elements that is in the flow inside a list in the same order that it's being collected. So then, actually, you have the list, and then you can say that, OK, hey, just the first element needs to be loading, and then the second element needs to be success. So sometimes you might see an error like this. Like, this is not really about flow, but it's actually about coroutines. If you're using coroutines with LiveData, or if you're using coroutines with flow, you might see that, which basically says that it had failed to initialize the main dispatcher. Because, like, main dispatcher is inside the Android main looper, which is inside the Android operating system. If you're unit testing something, by default, you don't have access to Android operating system. So how are we going to fix that? So we need to find a way to replace the main dispatcher with something, right? So the solution is using a test coroutine dispatcher. We're going to replace the main dispatcher with the test coroutine dispatcher. But how are we going to do that? So in order to do that, we can just write a test rule and then use the test coroutine dispatcher. Whenever the test is starting, we have a function call which is only available in the test. We can just say that, OK, set the main dispatcher, like change the main dispatcher with the test dispatcher, and whenever the test is finished, just reset the dispatchers. So that we're just actually doing a trick, like we're changing the main dispatcher with some other dispatcher, and then Android unit test is not going to complain. Yeah, as a TLDR, so Flow and LiveData are very similar, but they are not the same. So if you're doing one-shot request, in the repository layer, you can use either suspend functions, or you can even use Flow. But generally, you might prefer using suspend function if it's a one-shot request. And in the vModel layer, you can use LiveData or Flow if you're using some repeat on lifecycle API or some lifecycle launch when resume, etc. And if it's a data stream, then you just prefer using Flow, because you basically can't do it with suspend function. So you just prefer Flow. And in the vModel, you might prefer using LiveData or Flow with the corresponding lifecycle APIs. And LiveData, testing LiveData is a bit hard, but testing Flow is much more easier than testing LiveData. And if you have missed something, please go and check it out on my Medium account. I have also a written version of all this presentation there. You can just go and check it out.